Now, let us try to understand more about work. Suppose we have a surface here and a mass m is resting here. The mass displaces from here to here. One force acting on this is in this direction, F. Another force acting on it is in this direction, P. And one force acting perpendicular like this, Q. So now there are three forces. And the body actually displaces in this direction. So this force has a component in the direction of displacement, F cos theta. This force has a component opposite to displacement, P cos alpha. And Q has no component in the direction of displacement. They have other components which, if you want, we can write. This will be F sin theta and P sin alpha. And normal is balancing all of them. Now F has a component in the direction of displacement. So it does positive work. So force does positive work when it has a component in direction of displacement. A force does positive work when it has a component in the direction of displacement. A force does negative work when it has a component opposite to displacement. So this is doing negative work, P. And a force does zero work when it is perpendicular to displacement. Right, so Q is doing zero work. So the force vector can be resolved into two components. One parallel to displacement, one perpendicular to displacement. The parallel component figures in the work done. A force does positive work when it has a component in the direction of displacement. It does zero work when it is perpendicular to displacement. And a force does negative work when it has a component opposite to displacement. Now which force will always do zero work? Not normal, not mg. Which force will always do zero work? Which force is always perpendicular to displacement? Centripetal force. Centripetal force is always perpendicular to displacement. So centripetal force always does zero work as it is perpendicular to displacement. Right, remember that.